Okay, let's go through a couple of different examples using the TVM solver when we're investing money. So suppose you invest $75 per month at an APR of 4.5% for 45 years. So we're going to fill in what each one of these represents. So we have $75 per month, so that's negative 75 per month, so that's 12. And then we have 12 times something, and we're doing this 4.5%, so 4.5, and we're doing it for 45 years, so 12 times 45. Present value, remember we're starting with $0, and the future value is what we don't know. So that's a question mark. So we're going to go over to our TVM solver and type in what we see. I'm going to use the online version. So we have 12 times 45. We had 4.5%. We're starting out with nothing. We're going to give $75 each month, and we're doing it for, let's see, 12 times per year. And again, the 12 automatically changes. The P/Y and the C/Y are the same, and it automatically changed. And now, so there's a number here from the last thing that we had done. I'm just going to hit solve for FV and notice that it will just override whatever we had before. So we end up with 130,949. So 130,949 and 43 cents. Okay, so we end up here, so the future value will equal $130,000, 949 and 43 cents. Okay, what was the net gain? Remember, the net gain is the difference between the amount invested. So we invested $75 every month for 45 years. We need to know that. And then we're going to subtract this from our future value, from what we ended up in the bank. So we actually have 130,949 and 43 cents minus the 75 times 12 times 45. And I can do that in a graphing calculator or regular calculator or in Desmos. And so I'm just going to do that in Desmos. So we had $130,949.43 minus, again, we invested $75 every month, so 12 times for 45 years. And so we end up with a net gain of $90,449.43. $90,449.43. What was the percent breakdown for the investment? So in other words, how much was invested, and then how much was towards, so in other words, how much was towards our interest and how much was towards the amount that we invested. So amount invested percentage is going to be 75 times 12 times 45 over the total amount, so 130,949 and 43 cents. And then the interest gained percentage would be 90,449 and 43 cents divided by the amount that ends up in the bank, which is our 130,949 $949.43. And then those have to add up to 100. So we can do one of the two calculations and then subtract from 100. So I'm going to do the second one, since I have both of those numbers readily available. And we end up with 69.1%. So that's much better than the last investment. So if this is 69.1%, then we have 30.9%. So this is a much better job. This time we're earning a lot more money. So we're earning almost 70% versus investing 30%. So that's much better payoff for us. So let's look at this different problem. Suppose you want to have an account with $1.2 million after 30 years. So this time we want to end up with $1.2 million. So we want to end up with 1.2 million. So we have $1.2 million. That's what we want to end up with after 30 years. Okay, so we know that this is going to be times 30. The current APR is 6.75%. We want to make semi-monthly payments, so that's 24. That's 24 times, twice a month. So that's 24 times 30. Our present value is 0. We want to know what that payment is. So now we have our question mark on the payment. And so, again, if we go back to our TVM solver, so we have our 30 years, but semi-monthly, so times 30. And our interest rate, what was our interest rate? 6.75%. 6.75%. And we want, so we know that this was done semi-monthly, so 24 times. We want $1.2 million. So we want to know what that payment is supposed to be. And so this time we're going to solve for the payment. And the payment is $514.90. So the payment is $514.90 every, or twice a month, I guess I should say. Probably be a better way of saying it, so twice a month. How much will have been deposited in the 30 years? So now we would take our $514.90 times 24 times 30 to give us how much money we had deposited over that 30-year period. All right. So here's another one where we want to have $150,000. So again, that's the future. We want $150,000 in 18 years. What monthly payment? So 12 times 18. The interest rate is 8%. We're starting with nothing. We don't know what that payment is, and it's every month. So again, let's go and put that in. So 12 times 18. Interest rate of 8%. This time we are doing it monthly. And we want $150,000. We have $150,000. Our payment is $312.44. and this is per month. How much will have been deposited in 18 years? So we're going to take $312.44 times every month for 18 years. And let's go ahead and do that calculation. And we end up with we deposited $67,487.04. And remember, this gives us, when we deposit the $67,000, we end up with $150,000. But what would be the lump sum amount going rather than doing this every month, $312. So $312 every month. So that kind of like a car payment every month will earn us $150,000 in 18 years, but we have put in $67,000. If we do this as a lump sum, now we're solving for P. So what I need to do is take A, because this is a multiplication problem, 1 plus r over n to the ny power will give us what P is, because it's just a multiplication problem. So I have my $150,000, 1 plus 8% every month for 12 years, or sorry, for 18 years. And typing that into Desmos, we end up with $35,709.40. So this is about half compared to doing it every month at $312. So if you have $35,000, this is a much better way to get your $150,000. But if we can't afford just putting $35,000 into the bank, then we need this other option of $312 per month, and we'll still end up with the same amount of money after 18 years. So we've looked at comparing how much money is actually earned, how much is invested. Let's look at two other ways to compare investments. Suppose we invested money, got some real property, and we purchased something in the year 2014 for $27,000. 2023, we sold it for $43,000. What is the total return on that investment? So that is the relative change over the entire time period. So our relative change is new minus old divided by old. So 43,000 is our new number minus where it started divided by where it started. So new minus old divided by old, that's the relative change. And we can do that calculation and figure out what that percent is. So the relative change means that that investment grew 57.8%. Now we want to look at the annual return, so that's how much is given per year. Now we can't divide this by the 9-year difference because, again, this is compounding interest, not simple interest. So we have a different formula. So we're going to take the ending number divided by the beginning number, and then 1 over 9. This is similar to what we did in our exponential. And so if we go over to Desmos, we can type this into Desmos, and parentheses, divide 43,400 over 27,500, and we're going to raise that to the 1 divided by 9. And we end up with 5.2% annually.